Now we're going to be looking at some more difficult integration problems. And when problems become really difficult, where there's lots of variables, lots of different operations going on, you want to try to simplify it as much as you can. Now we're going to be looking at some more difficult integration problems. And when they get to be too difficult, we need to try a new method. That method would be U-substitution, which is just taking the difficult problem and simplifying it into an easy integration problem. But what's difficult is to find the part that you're going to turn into the u. So right now we've got an integration problem with respect to x. So my variable is x. And what we're going to do is change the variable to u, and when we do that, we're going to make this simpler. So when I look at this, I see that there's a product there. I see there's a chain rule with that being inside of the cosine. So it's really complicated, and I want to figure out, is there anything that I could get rid of? Usually, the part you want to get rid of is the more complex part of the problem. So here, if I were to get rid of that, and so I'm going to say let u be x to the fourth plus 2. Then what that would do is it would change and into that. So even though it didn't change much, we got a difficult part of the problem changed into something really simple. Instead of cosine of something complex, I just have cosine u. And so the trick here is to find a u that has a du within the problem. So I look through and I see, are there any derivatives? For example, do I have derivative of cosine anywhere? No. Do I have derivative of x cubed anywhere? I'm looking for a 3x squared. I don't see that. Do I have derivative of x to the fourth? 4x cubed. I do have an x cubed. So if there's a derivative in the problem, then that's probably your u. The derivative of x to the fourth plus 2 is 4x cubed, and dx, because we just did derivative with respect to x. And I've got that in my problem. So I chose a u, I do derivative of the u, and I replaced the part with the u. Now I want to do integration of this, but I have to have just one variable, and now I've got two. So I need to get rid of my x cubed dx. I need to get rid of my x cubed dx. And I see that right here in my du. So I'm going to solve for x cubed dx, divide 4 to the other side. And now I can take my x cubed dx and replace it with this 1/4 du. So now I've got everything with respect to u, and now I can do the integration of it. So we've got a coefficient which can come in front, and then I just have a very simple integration problem. The antiderivative of cosine is sine, and then we have plus c, and we've got that 1/4 in front. And so that is the integration of the simplified version of the problem, but we need to go back and think about what the problem actually was, and we need to plug our u back in. So our u is x to the fourth plus 2, and then you've got your plus c, and this is the final answer. That is the integration. So let's look at example 2. Okay. So it's not really that difficult, but because I've got this composite function, it's kind of like a chain rule, and we don't have a way to do chain rule in integration. So we're going to simplify this, and I think about what's the most difficult part of the problem. Is it the 2x plus 1, or is it the 1/2? And choosing the right u is kind of an art. You're going to get used to it the more practice you get. But even when you're really good at choosing the u, sometimes you'll choose the wrong one. So if I were to make my u the 1/2, I would see that there's no way to get rid of the 2x plus 1, and it would be a mistake. So what I'm going to do is let u be the 2x plus 1, And then I think about what is derivative of u. Derivative of that is 2 dx, because I just did derivative with respect to x. And then we'll just kind of see where that leads us. So that would change this into u to the 1/2, which is pretty simple. But in order to do the integration, I have to get rid of my dx, because I have to have the same variable. And so I need to get rid of dx. So I look here, I've got it there. So if I want to replace dx, I need to solve for it, divide 2 to the other side. So now I can replace my dx with 1/2 du. And so I've got everything in terms of u, so I can do my integration now. I'm going to bring that constant in front. And then I'm going to do the antiderivative. So I add 1 to the exponent. If I add 2 halves, I get 3 halves. And then I'm going to divide by 3 halves. I've got that 1/2 in front. And then if you divide by 3 halves, you're really multiplying by the reciprocal, 2/3. And then you've got plus c. So that would be the antiderivative, or the integration, but we need to go back and think about what it was originally. It had x's in it, so we need to put the u back in. My 2's reduced down to 1/3. I've got 2x plus 1 is the u, and then plus c. So that is my answer for example 2.